This is Algebra 1, spring test number 4. We got through standard form of an equation. It's picking up on part number 2. Number 10. Are the graphs of the lines in the pair parallel? Remember, parallel lines, if you look at them, look like this. They're not going to intersect each other. They have different y-intercepts, and they have different points, but they have the same slope. So you can determine by looking at equations if they're parallel or not based on the fact that they have the same slope. Unfortunately for this one, both of these equations don't show you what their slope are. The first one does, y equals mx plus b. You can see its slope is 4. So what you need to do is you need to determine, does the other equation have a slope of 4 as well? The only way we can determine that is by putting it in slope-intercept form. Make it say y equals mx plus b. In order to do that, we want to move negative 28x over to the other side. You undo that by adding 28x, or since we've been doing standard form, we know if you just move something from one side to the other, if you're not taking it away from anything else, you simply change its sign. So when it comes over to the right-hand side, it's positive 28x. There's still a positive 112 there. Remember, we put the x term first, so it'll say mx plus b. And then on the left, you still have a positive for y. Now undo 4 times y by dividing by 4. If you do it there, make sure to divide everything by 4, that and that. So this will cancel out and leave you with just y. That's what we're trying to get. 28 divided by 4 is 7x. And 112 divided by 4, well, 4 goes into 11. It goes into 8 twice. And there's 3 left over. It goes into 32 8 times. So we have an equation that says y equals mx plus b. You can see what the slope of this equation is. You can compare it to the slope of that equation. Equation asks, are they parallel? No, those lines are not, those slopes are not the same. One's 4, one's 7. So no is the correct answer. And when they actually explain why, they have different slopes. That is a simple enough explanation. They have different slopes. Number 11 tells you to write an equation for the line parallel to the given line that passes through the given point. Y equals mx plus b. Again, you can see what m is for this one. Its slope is 1/3. We said a second ago on number 10 that the slopes for parallel lines are the same. So the new equation is going to have a slope of 1/3 as well. Now you have a slope and you're given a point. We learned all about point slope form. So y minus y sub 1 is equal to m times x minus x sub 1. We'll plug those values in and be done with this. Your m value goes here. We said it's the same as the other one, so it's 1/3. Your x sub 1 value goes here. It's the opposite of this, not your x, excuse me. It's the opposite of this one. Your y sub 1 goes next to y, not x. It's the opposite of this y value, negative 19. You're going to put positive 19. And your x sub 1 value, it goes there. It's the opposite of this x value. It says negative 6. We're going to put positive 6. Now, it doesn't tell us what form of an equation to write it in. It doesn't say to put it in standard form, slope-intercept form, or point slope form. We just created point slope form based on what we were given. If you do point slope form, which is totally fine, and on the test it's in a different form, you need to know to convert it to slope intercept form or to convert it to standard form to match, which you should be able to do. Number 12 says tell whether these lines are parallel, perpendicular, or neither one. Over the last 2 problems, we said that parallel lines had the same slope. Y equals mx plus b. You can see the first slope. It's 5/3. So for them to be parallel, they would both have to have the same slope. So we got to find what the slope of the second equation is. Again, we need to make it say y equals mx plus b. Bring 6x over from the left to the right. 10y will stay right there. Equals 6x will become negative 6x, positive 16. Then divide by 10 to get y by itself. 10. Do the same here and here. Negative 6 divided by 10, the number 2 goes into negative 6, negative 3 times, and into 10, 5 times. So negative 3/5x. 16 divided by 10, the number 2 goes into both of these. It goes into 16 8 times and into 10 5 times. So again, What we have from this equation is now we can see what its slope is. Y equals mx plus b. So you could compare that slope to the slope of the first equation, 5 over 3. They're clearly not exactly the same, so they're not parallel. Parallels out. They would have to be exactly the same. Perpendicular lines have what's called the negative reciprocal when you're talking about the slopes. Remember, that's just a fancy phrase that means flip the sign, flip it, and then change the sign. From 5 over 3, if you flip that, it becomes 3 over 5. So we're so good, so far so good with that. And positive 5 over 3 becomes negative 5 over 3. Both of those things have to happen for it to be considered perpendicular. Not one or the other, but both of them. In this case, positive becomes negative, and 5 over 3 flips. Therefore, this is a perpendicular line, or these lines are perpendicular. If they would be not the same and not negative reciprocals of each other, you would choose neither one. Write an equation of a line that's perpendicular to the given line passing through the given point. 3x minus 5y equals negative 6. Again, perpendicular lines, negative reciprocals of each other. We have to take this standard form and make it into a form where we can see the slope. The easiest one is probably slope-intercept form for most of us. So again, bring it, make it say y equals mx plus b by bringing 3x over. You're left with negative 5y equals, it becomes negative 3x, and you still have negative 6 there. Divide by negative 5. If you do it there, do it here and here. A negative divided by negative is a positive 3 over 5x, and a negative 6 divided by negative 5 is a positive 6 over 5. Again, the only value you are interested in this equation is its slope value, its m value, 3 over 5. Perpendicular lines, negative reciprocal. So the slope of the perpendicular line, you will flip 3 over 5, and it will become 5 over 3. And positive 3 over 5 will become negative 5 over 3. So the slope of the new line will be negative 5 over 3 since it's perpendicular. Again, it tells you to write the equation. It doesn't tell you what form to put it in. We have a slope now, and we have a point, negative 9, 9. So we have a point and a slope. We're going to write point slope form. That's the easiest version. So y minus y sub 1 equals m times x minus x sub 1. M's value goes right here. It's negative 5 over 3, again, because we flipped it and changed it from positive to negative. And x sub 1 and y sub 1 are the opposite of x and y right here. Y's value says positive 9, we put negative 9. X's value says negative 9, we put positive 9. This is point slope form. Y minus 9 equals negative 5 over 3 times x plus 9. Again, once you have that form, if that's not an answer choice, if point slope form is not good, you have to convert that into either standard form or slope intercept form. Identify the slope and y-intercept of the graph of the equation, then graph it. Y equals mx plus b. Easy. This goes back a lot, so it's a lot quicker for us. Mx plus b. Remember, b tells us where to begin. It tells us to begin at negative 3. So we need to know if when we draw our graph, it'll look something like this, or draw a plane. We just need to make sure we can fit it. B's value is negative 1, 2, 3 on your y-axis. 1, 2, 3 is this point right here. The slope for this one tells you 1 over 3. Remember, slope tells you where to move. It's 1 over 3, rise over run. Positive 1 tells you to rise, means go up. So from that point, we go up 1. Positive 3 tells you to run 3 times to the right. 1, 2, 3. That point right there. Once you have 2 points, you can draw a straight line through those 2 points and have your equation that looks like that. The other one says, number 15 says y equals negative 5 over 4x minus 1. Again, we're going to have ourselves an equation that is going to go down 5 and to the right 4. So make sure, if you can't fit it quite in the middle, make sure you make it look something like this, where it's skewed that way a little bit, where you have more room in that bottom right quadrant or the fourth quadrant. Y equals mx plus b. Remember, the sign goes with b. It's negative 1. So on your y-axis, you begin at negative 1 right there. Your slope is negative 5 over 4. Remember, negative 5 over 4 tells you to rise over run. Negative 5 means go down 5. So 1, 2, 3, 4, 5. Positive 4 tells you to run to the right 4 times. 1, 2, 3, 4. There's your second point. Once you have 2 points, remember that's you can draw yourself a graph easily through it, and it'll look something like that. Number 16 says write an equation um, with the given slope and y-intercept. Again, it doesn't tell you which form to write. We learned point slope form, we learned slope intercept form, we learned standard form. They give us a slope and an intercept. So do the easiest one. We can make all three of them. I could ask you to make all three of them, and you could do it with this information. But do the easiest one. Y equals mx plus b. That's what we're given. So let's do it the easiest way. Y equals mx plus b. That's the first way we learned. M goes here, it's 5. B goes here, it's -4. Y equals 5x minus 4. And again, if you have to change that equation, you could change it to say y minus y sub 1 equals m times x minus x sub 1, or ax plus by equals c, standard form. Find the slope and y-intercept of the line. So backwards of what number 16 was. Y equals mx plus b, which you have to remember for this one, is the b value -10. The sign goes with it. So your y-intercept is equals -10. And your slope, or your m value, is not 6 over 5x. It's just what's multiplying by x, 6 over 5. You get confused which one's M and which one's B. Remember slopes. Mountains have slopes. Mountains start with M. One way you can remember. Use a slope and y-intercept to graph the equation. Y equals -4 over 3x plus 2. Again, we need ourselves a set of axes to look at. So draw yourself a pair of axes there. Your b value, y equals mx plus b, tells you to begin at +2 right there on your y-axis. Your m value, your slope, is -4 over 3. Remember, it's rise over run. Tells you to go down 4 and go to the right 3. So from that point we started at, go down 1, 2, 3, 4, and go to the right 1, 2, 3. There's your second point. With your second point, you can draw yourself a line through both of them. That'll look like that. Hopefully better than I just drew. Number 19, find the slope of the line. Toughest part about this one is finding two good intersections. Remember, don't pick an intersection that's in between two values. Pick one that has a good x value and a good y value at both spots. This is a good intersection right here. This is another good intersection right here. Okay? If you pick some that are further apart, you'll just have to reduce it a little bit more. It's not going to be wrong. Just make sure you don't pick one that's in the middle of two lines. So remember, slope is how many times you go up or down, how many times you rise, over how many times you go left or right. So if you start here, if you go up 1, 2, 3 times, up 3 times is +3. And you go to the right 1 time, that's +1. So your slope for this equation, you don't need to write anything as over 1. It's simply 3. Number 20, here's finding a slope passing through the pair of points. Again, it's quicker ways to do slope, but if you need to, you could always fall back on the fact that m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is the slope formula. If you label all of these, this is x and this is y. Remember, x comes alphabetically first, and this is x and this is y. You have to label one of them as 0.1, the other one as 0.2. That gives us our sub 1 and sub 2 values. So first things first, it asks you to do y sub 2. That's this value right here, 0. Minus, it asks you for y sub 1. That's this value, 6. Over, the next one it asks you for is x sub 2. That's this value right here, 7, minus the last one it asks you for is x sub 1. That's this value right here, 5. So 0 minus 6 is -6. 7 minus 5 is 2. -6 divided by 2, and negative divided by positive is a negative. 6 divided by 2 is 3. The slope is -3. Again, a lot of you excuse me, a lot of you are capable when you're looking at these two numbers or these 2 points of finding what the slope is a lot quicker than that. If you don't need to use the slope formula, that's fine. I never use the slope formula except to show it in case you need it. 21 says graph the linear equation. Again, y equals mx plus b. This is easy for us. It gives us a b to where to begin at -3, and it gives us a slope of 2. It tells us where to move. Remember, slopes are always fractions. If you don't have a fraction, you need to make it a fraction by putting it over 1. B tells you where to begin at positive or at -3. So we'll put ourselves a set of axes here. There we go. B tells you to begin. Remember, the sign goes with it. It says -3. So on the y-axis, the y-intercept, where it crosses through the y-axis, at 1, 2, 3, that point right there is where you begin, at -3. Your slope tells you where to move. M tells you where to move. It's +2, means go up 2, because it's rise over run. +1 tells you to go right 1, because it's +1. So up 1, 2, and to the right 1 is right there. With 2 points, you can graph an equation, and it'll look like this one. '22 says solve for y, then graph the equation. We're getting a whole lot better at moving variable terms across the equal sign with standard form. There's a -2x. Solving for y means you want to make y equals, and in this case, we'll make mx plus b to make graphing easy for us. If you bring -2x from one side to the other, if it's -2 on the left, it's going to become +2 on the right. You can't take it away from -2 on the right because they're not like terms. So it'll simply be +2x, and -2 doesn't move. This is solving for y. Y equals mx plus b. B's value is -2 again, just like the last few we've been graphing. -2 tells you to graph or to begin at -2. So on your y-axis, the intercept is -2 right there. Your m value is 2. And again, just like the last one, you have to make a fraction by putting it over 1. +2 tells you to go up 2. +1 tells you to go right 1. So from the point we begin at, we go up 1, 2, and to the right 1. There's our second point. With 2 points, again, we can draw ourselves a line straight through both of them, and it'll look something like that. 23 just asks you to solve these equations. The first one has variables on both sides. Remember, you want to get all your variables collected on the same side. Um, Bring the smaller x over to the larger one. 3 is smaller than 4. So if we want to bring this over, now we do have like terms this time. It's +3x. We know how to undo +3x. We subtract it. When you do it to that side, you do it to this side. So 4x minus 3x is going to be 1x. We still have -4. We still have equals -7. In order to get x all by itself now, we have to undo the fact that it says -4 with it. Undo -4 by adding 4. And again, if you do to one side, you do to the other side. -7 plus 4. This is still hard for some of you guys when you see something like this. You have opposite signs, one positive, one negative. That means you need to subtract them. 7 minus 4, and you get the number 3. And since 7 is the number that's farther from 0, or it's the higher absolute value, that's the sign you want to keep. -3. X equals -3. Use a number line if you need to otherwise. 6d plus d plus 5d minus 2 is equal to 5d. Before you can undo anything, you have to combine and simplify the left side and simplify the right side. That being said, the right side simplified. It only has 5d with it. The other side needs to be simplified. 6d plus d is 7d plus 5d is 12d. When we combine those like terms, we get 12d. Minus 2 equals 5d. Again, typically we would like to bring the smaller, since we have a variable on both sides, we would like to bring the smaller 5d over to the larger 12d. In this case, since there's a binomial on the left, or -2 over there, we don't want to have to move that one as well. So we'll bring 12d from the left to the right, the bigger 12 over to the smaller 5. It's +12d. In order to undo it, again, we subtract it. When you do it there, subtract it here. 5d minus 12d is -7d. On the left, when this cancels, you still have -2. Don't lose the fact that there's a negative there. Undo -7 times d by dividing by -7. When you do it there, do it here. D is now by itself is equal to negative 2 divided by negative 7, and negative divided by negative is a positive 2 over 7. No number goes into both of those. That is considered simplified. D is 2 over 7. 25, we're still solving. And 26, 3 over 5 times x minus 2 is equal to 5. We want to get x all by itself on one side of the equal sign. Remember, please excuse my dear Aunt Sally. Tells you the order of operations to solve. When you're simplifying one side, you follow that. But when you're undoing, you go backwards. You undo Aunt Sally first, then my dear, then exponents, then parentheses. So undo minus 2 here by adding 2. If you add it to the left, add it to the right. So 5 plus 2 is 7, and you have 3 over 5 x is equal to that still. Now this says 3 over 5 right next to x, which means 3 over 5 times x. Remember, in order to undo times something like this, you divide. Okay, so that's totally fine. We divide by 3/5. We do both sides divided by 3/5. We learned before, though, that dividing by a fraction is the same thing as multiplying by its reciprocal. So we would say divide by 3/5, and then we would have to change it to multiply by the reciprocal. Remember, is this fancy word. It means flip it, 5 over 3. So instead of having to write out that step, we could simply change it to multiplying by 5 over 3. That cancels it out. If you do it to that side, you do the same to this side. So now this cancels this. So you have x by itself. That's what we were trying to get. 7 times 5 is 35. Straight across. 7's over 1. 1 times 3 is 3. Just check and see if there's a number that goes into both of those numbers. You know, only the number 3 goes into 3. 3 and 1, but 1 doesn't change anything. And 3 times 11 is 33. So this is considered, even though it's improper, that's considered a simplified reduced fraction. And then number 26 is simply a two-step equation from the first 3 weeks of Algebra 1. 20 equals negative d plus 13. Undo your order of operations backwards by subtracting 13. When you do it there, do it here. 20 minus 13 is 7 is equal to negative d is still there. Now, some people still struggle with this because they see that negative d. They don't know what to do with it. They think they got to add d because it says minus d. If you wanted to bring d over to that side, you would do that. But this is the same thing. If you need to write it in, do it. This is the same thing as negative 1 times d. Put the number, had there been the number there, nobody would struggle with it. They would know just to divide by it. If you need to, write in the negative 1. Undo, multiply by that by dividing by negative 1. And when you do it to that side, do it to this side. A positive divided by negative is a negative. 7 divided by 1 is 7. D is negative 7.